Good morning, everyone. Thank you all for attending. Today, we're going to be going over the Flatline tool. With Flatline tool, I'm going to do a bit of an introduction on what exactly this tool is, what the StackStudio feature areas are that affect this tool and how to configure it, the definitions and some examples of what those configuration areas are, a few tips on how to get the best results out of this tool, then going over alarming, and if we have time at that point, I'll go over a bit of a live demo I have set up on a test system. I'm expecting to run pretty close to time, so I might just have to skip straight to questions, but if there's enough time, I'll cover a demo using a live system I have set up. So what is the Flatline tool? It is a ProcessNow task. It runs through any ProcessNow sequence that you want to add it to, and it flags and optionally invalidates online data that has stopped fluctuating, also known as flatlined. When data stops fluctuating, it's an indicator that there's some sort of issue with analyzing that live process gas. And so we want to make sure that we are flagging that data appropriately and also letting you know that there is an issue with it by alarming. Variation in these readings is expected just because that process gas tends to not be just stay at a perfect concentration. You'll always have some amount of variation in that concentration data. And if that stops, it's a good chance there's an issue with either pulling sample, the analyzer, or something else going on with the data controller getting that reading maybe. Some sort of issue is happening and that needs to be investigated. So this was originally developed for gas chromatographs over more as a feature for our refining and petrochemical users, but it has a broader application across the industry into power gen as well. With the GC readings, you're normally getting a reading roughly every about 4 minutes if for your H2S analysis, and 7 to 8 for hydrocarbon analysis. And when you're not used to seeing a value change often, it can take some time to realize that value hasn't changed in quite some time. So that's the original reason this was developed. But again, there are you can have this issue with pretty much any analyzer. It's just that the amount of time that you want to look at to see if this issue is happening or not may be greater for a GC than for other analyzers. This tool was originally developed and implemented in StackVision 6.13 plus. So if you are not at least at StackVision 6.13, you'll want to go ahead and upgrade StackVision to use this tool. All right, so the within StackStudio, you'll want to go to StackStudio Plant ProcessNow sequences. You'll see over on the right this image indicating the selection tree for that. And then once you're there, you'll select the sequence. You can either put this flatline application, flatline task in your hourly sequence, or you can create a new ProcessNow sequence. Typically, the sequence that's run every hour is just named hourly or hourly and has a couple other descriptors in it. But I generally think you should typically create a new sequence for this, which I'll go over the reasons of why when we dig a bit more into the tool. The daily sequence for this is not recommended. The reason is because that daily sequence is run over an entire quarter of data every night. So if you're using this tool within the daily sequence, it looks at every minute of data, and it can take quite some time to run. If you're okay with potentially increasing your ProcessNow time for that daily sequence by about 10 to 20 minutes, depending on your settings, then you can do that. But generally, just because of how much it extends that processing time for your daily ProcessNow sequence, we do recommend putting it in the hourly or its own separate sequence. Within the ProcessNow sequences, you can, like most areas of StackStudio, use the green plus in the toolbar to add a task to the ProcessNow sequence and select Flatline from the task list. Then you can use priority up and down arrows to move that Flatline task within your ProcessNow sequence. Usually the Flatline task can just be directly at the top of the sequence unless you're using it in your daily sequence, in which case Flatline task should go after the condition manager task for clear MDC. And there are some exceptions to this, but this is generally where that Flatline task will be within your ProcessNow sequence. From after putting the task into the ProcessNow sequence, you can select your sources and parameters and specify a flag to be placed on data during periods of flatline. So whenever a flatline period is detected, your data stops changing, then there is a data controller flag that will be assigned to that data. And we recommend using custom flags for this, the custom flag W if not in use. Otherwise, any other custom flag that's not in use, such as V, Y, X, or Z, will be most useful. So within StackStudio, here's what you'll see once you click on ProcessNow sequences. So like I was saying before, you'll go to your sequence, hourly, for instance, or there's a button directly below that to add a new sequence. After you've selected your sequence, go up to the green checkbox at the top, click on Add, and then this Add New Task pop-up over on the middle of the screen or to the right will pop up. You can scroll down and select Flatline from the list. So after that has been added, you'll want to shift the priority up or down within your ProcessNow sequence. If you're creating a new sequence, you can just leave it as the main task within that sequence. And then you can select your sources parameters down at the bottom, as well as specifying which data controller flag should be used. The argument for that is the -CF and then a space and then the letter. In this case, we're going with W. So that's one part of and with the source and parameters here, you can just select all. And the reason is because this is only one part of setting up the Flatline tool. The other part is going to be in its own separate section, which is that under StackStudio Plant ProcessNow Flatline. So over in the selection tree, it's in the same folder as ProcessNow, but it's closer to the bottom. You select Flatline, and you'll use the green plus in the toolbar to add a parameter to evaluate for Flatline data periods, which is why in ProcessNow you can just select all parameters. It might increase the runtime just a little bit. You can also just select the parameters that you're going to be adding to this Flatline feature area. There's also a button within this tool to import records. Most of the time you will not need to use this button. This was for importing a CSV file to where you can just quickly import these settings. You'll also, as soon as you've created a Flatline record, you'll set up the source parameter and settings for Flatline detection, which we'll dig into. So this is what it looks like in StackStudio. After you've clicked on Flatline, this Flatline tab will pop up. You can click on add a bunch of parameters, and then set up, okay, which unit do you want, which parameters on that unit, what's the, and then all of these Flatline settings, which we'll dig into. Importantly, the Flatline tool only looks at online data. And in this case, online is going to be determined by the parameter marked as QA enabled with a parameter code of uptime that is in the same parameter group and source as the parameter that Flatline is detecting. So if you go to the parameters tab within StackStudio, you can see the source the parameters are on. So in this case, all of these parameters, the H2S and the methane, are on unit 1. You'll see we have this unit on parameter, and this is the parameter that is in the same parameter group as all of the others that are on the source, is QA enabled, and has the parameter code of uptime. All of these have to be set for this to be the parameter that unit on is based off of. And this parameter, when it's on at the 1 minute interval, will be 1. If it's off at the 1 minute interval, will be 0. And this is just the state of the unit is fuel being combusted. So within the settings for Flatline, there's a setting for window. Window is going to be a rolling time period on a 1 minute basis where the data must be static before a Flatline is detected. So when this ProcessNow task is run on a minute or run over data, each minute within the time period this ProcessNow task is run over will look for the window value -1 back in the data and forward in the data. So if you have a window of 30 minutes, if you have a minute, data will be checked 29 minutes before that 1 minute data point and 29 minutes after that data point. Importantly, only data within the time period ProcessNow is run over will be flagged. So this is why I was mentioning it's a good idea to separate out the Flatline task into its own separate ProcessNow sequence, because the hourly sequence will only run over the previous hour. So if, for instance, you have this data and you didn't have a Flatline in hour 12 in this case, but then as soon as you get to hour 13, that hits the limit for that Flatline detection. Only hour 13 would be flagged because that hourly ProcessNow sequence is run over hour 13 and not hours 12 and 13. But if you have a separate ProcessNow sequence that you've set up, you can schedule that to run over the 2 or 3 hours prior and make sure to capture all of the Flatline data within the current data that is being processed. So for this window, during this 1 minute rolling window, if the unit goes offline, the data point will not be considered flatlined. So if we go back to that same data set that we were looking at, ProcessNow is being run over hour 13 to 13:59, and hour 12 is where the flatline started. If, for instance, there unit on goes to 0 for any part of hour 12. We can see that hour 13, because each one of those data points in the start of hour 13 is looking back into hour 12 for its window. It sees that there was an offline period, and so it's not being considered flatlined because it's not meeting that window criteria. In this case, I had the window set to 30, so it would look back from minute 1300, 30 minutes, and say, okay, that minute 12:48 here is the unit on parameter was 0. That means the unit was off, so this data point is not flatlined. And this may be important when considering your window. You might want to decrease that window accordingly if your unit is constantly up and down. So the next setting within Flatline is tolerance. Tolerance is going to represent the amount of variation that's required during that window before the data is considered static and flagged as flatline. So in this case, if we have a tolerance of 0.1, that means the value within the window must fluctuate by greater than at least 0.1. So if we go back to this example, if we look at that minute 12:48 again, and ProcessNow is being run over the hour 13 with a window of 30 minutes. If we go back in each one of those minutes in hour 13, 30 minutes, we see, okay, this one data point at 12:48 fluctuated by more than 0.1, which was what our tolerance was set at. So there isn't a flat line because we had that small amount of variation. The next setting is going to be floor. This is going to be the value where flatline consideration is going to be ignored if the data is less than or equal to that value. So if we had a floor value of 0, only values above 0 would require the variation specified by the tolerance. Otherwise, we're going to ignore it. So looking through this data, if for instance, the unit was on and our H2S was just 0 for that entire data period, we would, if the floor is set to 0, then that would be fine, and that data would not be marked as flatlined. So this is the next setting is going to be exclude central flags. Well, actually, I mistitled this one. This is exclude. Yeah, actually, no, this is the correct name. Sorry about that. It's exclude central flags. These are data masks. Flatline will ignore. These are not to be confused with data flags. Flags and masks are a little different. Flags are applied by the data controller and some ProcessNow tasks. Masks are checkboxes for that data that is basically, okay, was this data missing? Yes or no. Was it invalid? Yes or no. So on and so forth. Valid options for this setting include diluent capped, exceedance, invalid, maintenance, missing, OOC, out of range, shutdown, startup, state invalid, substituted, suspect. This setting is mainly used for controllerless DAS. If you have a data controller, there's another setting I would recommend instead of these that we'll cover next. For this, the difference between flags and masks, if you look at data lab fields, this little checkbox here for flags, that will pop up its own separate column that has the data controller flags that were applied to the data. Those are flags. The central flags, also known as masks, are basically everything else. There's some exceptions, but almost everything else is going to be a mask. There are some fields in here that are numeric, like reason and action codes that aren't really a mask, but all of the ones in here that have that pop up with a column that either has a checkbox in the column for yes, it was missing or invalid, or no, it wasn't, are what we mean when we say masks or central flags, not to be confused with the data controller flags. So how this setting works is if the mask is present during any part of the window, the data point is not considered flatlined. So if we go back to our same example, looking at that minute 12:48, if this minute had an invalid mask and you had set this setting, the flatline tool to ignore invalid masks, then the data in hour 13, when we are running our ProcessNow task, would not be considered flatlined. The next setting is exclude controller flags. These are the data flags that Flatline will ignore. These are flags set by the data controller or other ProcessNow tasks. The recommended setting for this is that less than. This is the setting for invalid. By using the less than flag, you're excluding data that is invalidated for any reason, such as calibration, maintenance, bad status due to a fault signal, Modbus communication dropping out. It's largely a catch-all. So using that setting will help to avoid marking data as flatlined that you're already getting another alarm for, such as an alarm for if it's in maintenance or if the entire data period is invalid due to going out of control or running a calibration or linearities or whatever is happening at that time. So valid options for this setting include any data controller flag. And these are mainly used for a DAS system with a data controller. And if the data controller flag is present during any part of the window, much like with the central flags, the data point is not considered flatlined. For the data controller flags, most of you have probably seen this mouse pad that we have that lists out all of the flags. This will exclude the calibration report flags, as those are just on calibration data, but any options from this flag list are valid options to include. This data controller flag setting here for validation will set this invalid flag down here, which is the reason why we use that less than flag, and why that flag is recommended specifically. You all might have some cases where you're getting data flagged with other custom flags for various reasons that you want to include in this setting, but largely that less than flag will catch most scenarios. So the next setting is set invalid. This is just a checkbox within the Flatline settings, and you check the box if the Flatline tool should flag data as invalid. In the examples I've been showing, whenever I've had this setting enabled, so that controller flag of W is being applied to the data whenever there's a flatline period that was detected, as well as that invalid setting. Just as note, if flatline is run over data later and that data is no longer flatlined for some reason, maybe it was filled in from another data source, then Flatline will remove the invalid NW flags when it's run back over that data. other flags will not be touched, such as all of the other controller flags that will be put on the data. All right, so some tips for setting up the Flatline tool. You'll definitely want to review your historical data when you're determining the tolerance, the window, and the floor. See, okay, kind of play around with, all right, looking back at this data, around here, the analyzer doesn't very much when it's down at those lower levels. So maybe we set the floor at something like 5 ppm. When looking at the window, maybe you want to set that at 30 minutes or more for a GC when you're expecting readings to update pretty slowly, or you might want shorter windows if you have an analyzer that is constantly giving updated values. And then when determining that tolerance, again, just looking through that historical data and saying, okay, within an hour when the unit's operating, we typically vary by about this much. And if we stop, we'll want to flag that data as flatlining. You'll also most likely want to schedule a separate ProcessNow sequence and schedule it to run at least hourly. If the window is less than 1 hour, you'll want to run it over at least the past 2 hours, maybe 3. The window, just to be sure that we are catching all of that flatline data, and if it started flatlining in 1 hour and bleeds over into flatlining into the next, we want to make sure that we catch both hours instead of just one. And if the window is greater than 1, we round to the nearest hour and just kind of add another hour for additional historic data to run over. Maybe even more than just adding 1 hour, maybe a few, depending on how large that window is. This can be run in the daily sequence, but not recommended as it will add significant time to that sequence. But if you're all right with that daily sequence taking just a little bit longer, then you can go ahead and add this Flatline tool to it. But you probably wouldn't want to add alarming necessarily to that tool, which we'll cover, just because generally with that alarming, you want more real-time alarms rather than, okay, that's happened to this data at some point in the past, but it's up to you how you want that alarming as well. All right. So with our alarming, the main way that we'll be doing alarming is going to be through Xscript, and you'll get there via, if you go through StackStudio, it's under ProcessNow Condition Manager to set up a condition that will be used within this Xscript task. And then you'll add that Xscript task to the ProcessNow sequence and specify the source and parameter. And you would add that Xscript task how we went over adding the flatline, only instead of from the drop down, you would select Xscript instead of flatline. So if we look through StackStudio, if we go down the tree, we'd look to Condition Manager. That would then open up this Condition Manager tab that's a little bit cut off here. We would then click Add to add a condition, name the condition whatever you want, and then put the condition text into it. And I've created a couple Xscripts as options that should cover what a general amount of what you would want for alarming. So this first Xscript option is going to be this text, and you'll be able to, I believe this presentation slides will be sent out later, so you'll be able to look through this and copy this down. I added in some comments in here for some settings that you might want to change. And this condition is set up very general. I have the input, source, parameter, bit, and controller at the top. What these are going to do is if the source or parameter has the flag for flatline, which in this case I've set as W, then it's going, whenever ProcessNow is run, it's going to look and see if that data has flatlined and if it is continuing to flatline within that ProcessNow. And if you just care about if that data has flatlined, you can remove the lines in that condition 1 that say else set flat equal to 0. And then if there is any flatline period within your the data that this ProcessNow task is run over, it will flag. It will just send out this alarm, which in this case is going to be toggling a data controller bit. And that's what the input bit and controller are. That is for choosing a data controller that you want this indicator to toggle on, and then data controller output, or also known as a bit that you want toggled. And this is useful for if you want to set up other alarms within the data controller, if you want to set some other flag on the data, or if you want to set up an input line control alarm within StackStudio for whenever this bit toggles, it will send out an alarm, and then as soon as the flatline has stopped, that alarm will return to normal. So the settings for this, setting this up, you would add it to your flatline sequence, and it would just go after the flatline task. And then in this, in the other arguments, you would set up what you want input into this, into the script. Source is going to be your unit name. In this case, we have our source as unit 1. The parameter is going to be the parameter name, which is parm. In this case, we're setting as H2S. The control is going to be the data controller name, which log 01 in this case. And the bit is going to be the data controller output that we want to toggle anywhere from 001 to 999. In this case, we're setting bit 42 is the one that we're using. And then the last parts, you'll want to make sure the interval that the script is running over is at the 1 minute interval, and the condition manager is going to be the one that you will have set up for the condition that I had on the previous page. And again, this toggles the data controller output. It can be used on a dashboard, for instance, if you want any operators who might be looking at that dashboard to see, okay, this data is flatlined, and you can put up a little indicator light on that dashboard, or you can use it for various other purposes and alarming within your configuration. The other option, this is option 2. Instead of toggling a bit, this just directly sends out an alarm within StackVision. And for this, again, it's going to, if the flatline event occurred and is still occurring based on when this ProcessNow task was run, you would have this alarm come in. But if you want to just, if a flatline event occurred at all whenever this ProcessNow task was run, again, in that condition 1, you can just remove that line that says else and set flat equal to 0. So for this, same way, you just add this Xscript task to your ProcessNow sequence, interval of 1 minute, and then condition manager, select which one you just put the condition into. In this, I am specifying in other arguments, inputting that the source is going to be your unit name, the param, again, your parameter name. So the source, in this case, unit 1, the parameter H2S, and then ALM name. This is going to be your exception name. And you can find these exceptions in system settings and alarm messages. And this alarm will trigger in StackVision every time this ProcessNow sequence is run. Unlike the other one, which just sets a bit that can then be used in a separate alarm that would only stay true until the flatline is over. This one will alarm every time the ProcessNow sequence is run. So if you're only running this flatline tool hourly, this is probably fine. You would just get an alarm every hour until the issue is resolved. If you're running it less than that, you might want to go with option 1 instead of 2, as with option 1, that would prevent the several alarms coming in if, for instance, you're running this ProcessNow task over a shorter period, like every half hour or 15 minutes. All right, so at this point, I think we have enough time left for me to run through this demo on this test system that I have. So I'm going to switch over to this screen, and I will put up a magnifier on this, and let's magnify that a bit more. Yeah, let's go with 200%. All right, so in this, I just have Data Lab pulled up with our parameter of H2S and some data that is in there, as well as our unit on. But the flatline tool, this is the 1 hour data, and the flatline tool is run over that 1 minute data. So if I go down to select the date range, I can select 1 minute here and retrieve that data. And then just going through looking at this data for just today, you can see the H2S is changing and updating for unit on. I just have that set to 1 for each one of these data periods. And then you can see that the value here for H2S went and was stagnant starting at 720 and has flatlined, and we're not getting any updated values within that 7 o'clock hour. So if I look at my StackStudio settings, and you can get to StackStudio just by going to your configuration, StackStudio. You'll then be prompted to log into StackStudio. If I go through StackStudio and I look down for, let's see here, I go down the selection tree. I can go down to ProcessNow sequences. So here I have this ProcessNow sequence set up. I have set up a sequence called Flatline. In this, I have that Flatline task. And again, to add that, you can just click on Add up here at the top, go down through and select the Flatline task from this drop-down menu. You can also type and have it jump to what you type. So Flatline, click this and click OK. In this case, I've already added it. I have the controller flag it's going to set as W, source and parameter is all, and then I have set up both of those 2 X scripts for alarming so that you all will see how these 2 different alarms will work. So for this setting this data controller bit in our controller 1 on bit 42. I have also set up an ILC alarm, input line control alarm, and that's under digital lines, data controller, digital lines. If you go to your data controller and go down to line 42, I've set up this H2S flatlined and have a flatline alarm on H2S, and also additionally setting a data mask of a suspect on that H2S. For the flatline settings itself, if I go under ProcessNow, go down to flatline, for H2S, I have flatline set up with a window of 30, a tolerance of 0.1, floor of 0, and we're going to set invalid and exclude data controller flags of with the less than. So if there was any invalid data, it would be excluded. So for this, I will go ahead and acknowledge this alarm so we can just see the new alarms come in. All right, and I am going to go to Tools, ProcessNow, the Flatline ProcessNow. I'm going to override the date and ending time today. So if you were to have this ProcessNow task scheduled, you could do that just under Configuration, Task Scheduler Wizard. You would go through this wizard, set up the flatline tool, create a new task, then a ProcessNow sequence, flatline, and we would just want that to run hourly, and you want that to start before your hourly ProcessNow sequence, whenever that might be. When you want that to start, and then you'll want to set the now minus, in this case, maybe I want now minus 2 hours, just because that flatline window is 30, and I want to make sure it catches a flatline that may have occurred across an hour boundary. Those settings should be all you need. Then you'll just enter in a service account username and password. That service account should have a password that does not expire. If it does, then as soon as that password expires, this task will stop working. So you'll want to use a service account for that on your StackVision server, and then you can name this task. And that will create the task and run it on however often you want to. In this case, I'm just going to have this flatline task here. I'm just going to run it over that 7 o'clock hour. So that's 7 to 7:59. And I'm going to run this manually and just select to run over this data. And there we go. There is the data alarm that just came in. So that's one of the alarms. This is the one that you can see. I've just created an alarm that is this data has flatlined, start and end, 7:59. And then you'll just see the source parameter and interval, the value of 30.32. The other one's going to take another minute to come in just because it is based on the data controller input. But if I go back to the data lab I was looking at and retrieve that data, and scroll down here to the bottom, you can see that the tool started marking that data as invalid. And if I pull up flags, you'll see that the data controller flag of W has been applied to this data. And then looking in that data controller, you can see that output 42 is toggled because of that flatline. All right. And let's see if I unclick this just this last minute. So say this data here was fine. On this last minute, whatever happened was fixed. So I'd set it to 30. And let's go ahead and save that. And there's the other alarm that just came in. So if, it takes a little bit longer because of data being pulled. We'll see this one starts at 9:46. This is because that's when the ProcessNow task was run. But if you're running this out over just the previous hour, it would come in a few minutes after the top of the hour for data that has flatlined. And then you would see the start and end. So in here we have a start but no end. So this one would stop as soon as the data is, as soon as the data has no longer flatlined, and you wouldn't get another alarm every time this ProcessNow sequence runs. So I'm going to look at that data again, and this is the setting I have set up to where if the issue fixes itself, we're going to identify that flatline, but not mark it, but not alarm. And again, if you just want an alarm anytime the data has flatlined within a period, this ProcessNow sequence runs instead of only if the issue hasn't resolved. You can just get rid of in the condition these two lines, this else and set flat equal to 0. So in this case, I'm acting as if this was fixed itself. I'll pull the data controller up here and run that ProcessNow task one more time over that data. We look in the data controller now. That might not have done it. Let's see here. Okay, yep. There's the 30. So this last minute no longer flatlined. And okay, the output is still closed. Oh, okay, there it just went. Just took a little bit longer. All right. So then we look here as soon as we will take probably another couple of minutes, but as soon as that pulls in, you would then see this end here be set to the end time as soon as that digital bit was no longer closed. All right, So that is everything that I had for this presentation. Are there any questions about the Flatline tool?
All right. Well, thank you so much, everybody, for attending, and I hope you have a great rest of your day. Thanks so much, Alexis.